that has a seed is actually a fruit. Today what we're going to do, this has been a very naughty pickle, so we're going to electrocute it.
Yeah!
On this device I've got two forks. They are connected. Sorry, science is calling. They're connected through the little cables in here, and I'm going to put one side of the tine onto this one side, and the other side here. If I could get, Seth, could you get the lights for me? Ah! Just kidding. So as of right now, it's not doing anything, but in just a moment, we're going to see that little pickle catch fire. Safety always first, so I've got my safety glasses on. I'm going to move everything back away. I'm going to take my plug in. You'll see in just a second, it'll start sparking. There is a chemical and electrolysis of the reaction happening inside. Do you see the flames? What's happening is that all of that salt inside is actually being electrocuted. So that pickle is cooking from the inside out. The electricity is going straight through that pickle, and Seth, if you'll get the lights. Not bad.
It's smoking.
So the next thing I want to do, how many of you are in middle school? Raise your hand. You know what middle school is like. It's a lot of pressure, a lot of stress, a lot of things that are happening. Oh, by the way, when you cook a pickle like that, it does not smell good. We all know the difference between an explosion and an implosion. Explosion goes, implosion goes in. So what I've done on this little can, I've got a little bit of water just inside, and what I'm doing is I'm heating it up on the inside. All of the air is becoming very, very less dense, so it's actually taking up a lot less volume. So what's happening is that the air molecules are starting to expand. I'm going to take it off of this in just a few moments. I'm going to put it into this cold, cold water. So when that happens, we're going to see something implode. While that's happening, who can tell me what this is called?
Styrofoam.
Styrofoam. Do you know how many pounds per year we use of styrofoam?
Billion.
200 billion to be exact. If I were to put this in water, is it going to dissolve?
No.
No. Well, 200 billion pounds of this stuff makes its way into our landfill every day. Well, the thing about that, get nice and warm, is that some places, 3M for example, have figured out how to make packing peanuts out of cornstarch. Cornstarch you can eat. Packing peanuts made of cornstarch, not a good idea. So what they do is they make them out of the cornstarch, but what will actually happen is that they will dissolve right in your hand. So it's kind of like ooey gooey science. Some places, Hallmark, for example, are making biodegradable greeting cards for Earth Day, so that when it rains, they just evaporate right in the atmosphere. It's kind of interesting. I have a friend, and his name is Jason. I don't know if you know anything about Jason or not.
He's our brother.
Is he your brother?
Yes. Jason.
Jason just happens to like Galatians 5:22 and 23. And the cool thing about Jason is that he is full of love. You're acting like that's weird. He's also full of peace. Styrofoam is a polymer. Okay, it's a polypeptide polymer. And actually what you're looking at is a whole bunch of macromolecules put together, and it's just a bunch of air. That's why packing industries use them so well. They use them to protect valuable shipments and to keep things protected. Inside of Jason's head, aside from Galatians 5:22 and 23, is a chemical called acetone. Acetone is used to dissolve styrofoam. But the thing about it is that there's not really a good environmental way of getting rid of acetone. So you can't just dump it down the drain like you can water. So as this is dissolving, what's happening is that all of these little polymers are actually chemically changing into air bubbles. That's not bubbling yet. No, I'm not going to kill Jason. Who said I was going to kill Jason? No, I'm not killing him with kindness. We all need to have some self-control, people. Okay, you hear that? Oh, that's the can. Thank you, Jason. Leave that right there like that.
I can dispose of it.
I guess
You have to take it to a like a paint store, Lowe's, other places like that, where they can actually recycle it for you. All right, so air pressure. I'm going to take these tongs, pick this up, but I'm going to pick it up and I'm going to quickly invert it into this cold water. All of the air and the atmospheric pressure is going to cause this can to implode. Just like that. So what happens is that all of the air actually rushes out of it and it collapses all by itself. Who knows who Daniel Bernoulli is? Anybody know who Daniel Bernoulli is? Has anybody ever flown in an airplane? Well, if you've flown in an airplane, I have an airplane right here. Daniel Bernoulli was a researcher that figured out that a fluid, whether it be air or water, can actually cause things to float. And a lot of times, when you see a different kind of material, like a ping pong ball, they'll float because the air pressure around it is lower. When it's lower, it causes it to float. But I like to do things a little bit bigger and better. So I've got my friend the leaf blower. And we're going to do the same thing to that we do with the ping pong ball. So let's make it bigger and better. Seth, when I turn this on, if you wouldn't mind putting that in the direction so that we can get that to hover too. Are you ready? Bernoulli's principle also applies to toilet paper. Because if you'll hold this, you can stand up. You can stand. I'm not going to get you. Same thing can happen. We're going to have to use all of that toilet paper in a little while. If you take a penny and put it inside of a balloon, you can actually use centripetal force, and you can cause it to actually run around the inside of the balloon. No big deal, right? Same thing with a beach ball. Same principle, leaf blower, beach ball. Okay, so one last thing, couple of the last things I've got done that I want to try. This is a vortex generator. It's just a great big garbage can that I've cut a hole in, and I put a shower curtain on this one side. No biggie. You guys can't see the air. Well, inside, all of the air is being taken up, and it's a little bit easier to see if we put some smoke inside. This table right here has cups. If you wouldn't mind, put those cups on your head, please.
Okay.
Let's see if we can do some target practice.
Wait, but I got skateboard goggles on.
No. Why would you do this?
Baby.
I have my head isn't big enough.
See, we get you all.
All right, here we go. 1, 2, almost. Boom. Got it. Got it. Got it. Got it. Got it. Got it. Why didn't you put it back on?
Good aim.
Oh yeah, I forgot about one thing. Liquid nitrogen. Have you guys ever heard of that? How cold is it? Does anybody know? Negative 321 degrees. Right?
Celsius. This guy took a
Fahrenheit.
This guy took
If they were Celsius, it would be pretty much absolutely
fire
zero.
extinguisher versus a flamethrower.
Liquid nitrogen boils at room temperature. Okay? So right now in this container, we've got liquid nitrogen, and it is so cold that it's actually snowing on the outside of this container.
Jesus.
Taking a little bit of water in here.
They said they would teleport. And they exploded.
Pour a little bit of liquid nitrogen in here. You can hear it boiling. And what's cool is that you can make a little volcano right in front of it.
It's a vape.
Yeah, big to the
Not this, unless you want something really big and explosive.
Yep.
Okay? Now, I've always put liquid nitrogen into water, but I've never put water into liquid nitrogen. And I'd like to try to do that. Alright? I've got some garbage bags that you probably want to put them on because you might get wet.
They're gonna explode.
Yes.
I'm just gonna
Oh.
back up. This will be. This is gonna be great.
And this is where we might want to use some hearing protection. Did you say you wanted some?
Sure.
Alright. Seth, would you grab
Oh, shoot, you're right,
those,
enough.
garbage bags and hand them to people?
I'm not lucky to hear what
Anybody else? No? Anybody else? Okay, cool.
I can't put it on a video.
So in this container, I have 50 liters of liquid nitrogen that I borrowed from my friend at R&M Welding. And like I said, it's negative how much? 321 degrees Fahrenheit.
You need one? No.
We breathe 78% nitrogen. So, the other 22% 50%, roughly. It's made up of oxygen and other innate gases. Pour a little bit of this in here. Alright, and in this container, I have a little bit of water. You may want to back up. Like where they are. I'm going to take this hot water and I'm going to dump it down in there. Don't know how much insurance you guys have, but you ready to find out? 3, 2,
Oh, it wasn't as loud as we thought it would be.
so when set designers want to make a cloud,
Look how cool
they take
that
hot
is.
water and put it into liquid nitrogen. You can come up and stand in there. It's not going to hurt you.
Wow.
Yeah, don't touch it. It's 320 degrees Fahrenheit.
You want to touch it, but don't.
No. I won't touch it. Because it'll freeze your foot off.
Or would that damage the carpet?
Don't touch it.
That's right.
Notice he wore protective gloves.
Sam, this is yours. I grabbed it before. I said she should in order to we're kind of.
Bottom is like an ice volcano.
You said go. My toes are freezing.
With the damage the carpet. So cold.
Let's not touch it. It's really, really cold and it will cause
Seth,
instant
back
frost.
up. You don't want to lose fingers.
Don't stick your hand in it.
Yeah.
No, it's nice.
The neat thing about liquid nitrogen, if we put anything in here like,
Where's the balloon?
Where's
There.
the balloon? You got it?
It's gonna pop.
Put them in the middle and see what happens.
Oh, it's gonna do more four. That's what I'm waiting on. Shane, it's probably gonna pop.
Ah! Alright, so there you go. Real quick, short science demonstrations you guys can do at home.
Wait, can it pop?
What does it
No,
do?
it's just going to contract. It's not going to get any.
Is it gonna freeze?
It could. I mean, we can pour more on it.
Yeah, pour more on it. Look at the bottom. Oh my god. Is that still gonna be usable? No.
The balloon or the bin?
Big.
Yeah.
Yeah.
As soon as it thaws, it'll just go back to its original shape.
I thought it was gonna like
There we go.
Can I get that penny?
All the water, no, it's frozen. All the water is frozen in the ice.
Yeah, see.
Wait,
Where is it? Penny. I don't even
The penny?
Yeah, but it's right there.
Don't touch it. Just leave it.
It's onion.
Like we're all like.
Yeah, it's right there.
None of us see the penny. Oh, I see it. Oh, okay, it's under.
Don't grab it. Don't do it.
Okay, let me get the glove. Let me get the glove and we'll get the penny out. Oh my gosh! This is some really cold, hard cash. Really cold. Breathe on it.